One of the most useful things in mathematics is setting up what we call proportions. Proportions are where you have two ratios or two rates that are set equal to each other. They have incredibly many uses in mathematics. You have to just make sure you set up a ratio that makes a proportion that makes sense to say these two ratios equal each other. And then you also are doing this so you can solve for an unknown. You can set up proportions so that you have an unknown in one location in the proportion, then you cross multiply to solve for the other unknown. The following example just shows you how to cross multiply. So we're going to solve each of the following proportion problems for the given variable. We're going to round to 2 decimal places as needed. So one of the things we have is we have x over 25 is equal to 1 over 5. So we're going to do what we call cross multiplying. It means the x over 25, the 25 in the denominator, is going to cross up and multiply by the 1 in the numerator of the 1/5. The 5 that's in the denominator is going to multiply up to be times the x. So what we end up with is 5 times x is equal to 25 times 1. Solving this is as simple as just getting rid of the 5 that's in front of the x. So you divide both sides by 5. So you get x is equal to 5. 4 over x equals 3 over 7. So that's my ratio, my proportion I'm dealing with. Again, you're going to cross multiply. You're going to take the 4 in the top times the 7 that's in the other denominator. It's going to equal the 3, which is in the top of the other fraction, times x, which is the denominator of the first fraction. And then again, we're going to solve this by just dividing both sides by 3. So this one's not going to come out to be a nice whole number. It is going to be most likely an irrational decimal. So you have 4 times 7 divided by 3. And that's going to be 9.33. And the 3 keeps repeating. And so we did say we're supposed to round to 2 decimal places. So we're going to go ahead and make this as 9.33. Most of the time you need to set up proportions before being able to actually solve them. There are many ways to set up proportions, but a very useful way to do it is to think about having a rate in the first ratio, and then the second ratio, make sure that the terms with the like units are crossing each other. To give you an example, let's go ahead and set up a proportion and solve for the unknown. We'll round to 2 decimal places as needed. So if a scale on a map is 1 inch to 10 miles, what is the actual distance between 2 towns that have 5 inches apart on the map? So again, first thing I'm going to do is use my things I know and set up that rate. So I have 1 inch over top of 10 miles. Now, it really doesn't matter which one you put in the top or the bottom. I just did it in that fashion. Remember, 1 to 10 is a fraction. So that's where I get my 1 inch over 10 miles. So what is, so we're going to do an equal sign, the actual distance between towns that are 5 inches apart. So we now have 5 inches. Again, inches were in the top of the first one. So make sure you put inches in the top on the second rate. And then we want to know how far apart they are, what that distance is. So we need to find that distance. You can give it any name you want. I think I'm going to call that one M for miles. You can call it anything you want. It's just an unknown. You can even call it unknown if you want to write out unknown each time. Then we're going to cross multiply. So we have 1 inch times M, and then 5 inches times 10 miles. So again, remember with cross multiplying, the 1 inch is going to be multiplied by the opposite denominator. The 5 inches is going to be multiplied by the opposite denominator. Again, I want to solve this, so I want to divide out this 1 inch. When I do that, I'm left with M is equal to 5 times 10, which is 50, divided by 1. But now when I notice this, my units do some fun things. My inch and inch cancel, and I notice I have just miles left. So that's my units I have left. So numbers, units cancel the same way numbers cancel. Let's do one more. Suppose you can walk 1 mile in 20 minutes At this rate, how long would it take to walk 8 miles, assuming you do not take any breaks? And you're walking a constant speed. So again, I'm going to go ahead and set this up as a ratio. I notice I have 1 mile in 20 minutes. So that actually is my rate, 1 mile per 20 minutes. It's going to equal, we want to know how long it takes to walk 8 miles. So again, remember the way you set these up is you've got 1 mile on the top, you should also have the 8 miles in the top. Over, and then you'd have how far you walk, but we don't know how far we walk. That's our distance, so we can just call that D. Cross multiplying, we have 1 mile times D, and then we have 20 minutes times 8 miles. Again, I'm going to solve for D, so I'm going to divide through by 1 mile on both sides. Then we're going to have 20 times 8, which is 160. The miles actually cancel in this case. So we're going to see my miles has gone here and my miles has gone there, and I'm only left with minutes. So it's 160 minutes. That's how long it would take you. Again, assuming you haven't stopped, don't take breaks, and so forth.